Yep. Look at this, 8-3 geometric sequences and series. Wow, I feel like I've learned this already one time before, maybe back in Algebra 2. Well, if that's what you're thinking, then yes, you are correct. Yep. So, we need to do a little review though. And we're going to, of course, like always, extend your knowledge a little bit. Today we're going to be recognizing, writing, and finding nth terms of geometric sequences. We're going to find nth partial sums. We're going to find sums of infinite series. And yes, our favorite, we get to model and solve real-life problems. So thinking back to what a geometric sequence was, well, this is a time where you have consecutive terms that have a common ratio. And if you have a common ratio, this is different than a common difference that we had with arithmetic. This is what we call a geometric sequence. Meow, meow, meow. So your R is going to end up being your common ratio. Once again, your A sub 1 is your first term. A sub n is your nth term. So let's look at our first example and let's find out what each of our ratios are. So if we're trying to find, get it? Let's find out our common ratio, what they are. I don't know if you heard about the new pirate movie coming out sometime in December. I think it's rated R. Sorry, I had to get that in. Okay, so anyway, whenever you're talking about a geometric sequence, you are actually multiplying, you're not adding. So if you're going to go from 3 to 9, well, we multiply 3 times 9 to get a 9. We multiply 9 times 3 to get a 27. 27 times 3, and on and on and on. So you notice that your R is a 3. Now, where is your R located? It is a base underneath an exponent. So let's look at what we have for B here. If we have a 10 times what gives us 20? Well, 10 times a 2 gives you 20. 20 times 40, I can't even talk. 20 times 2 gives you 40. 40 times 2 gives you 80, and so on and so on. So that means your R here is going to be a 2. Notice it is a base. It is not a 3 times n or a 2 times n. It's 3 to the nth power, to the nth power. This is not as much fun, but notice your signs are alternating, negative, positive, negative, positive. So you know you have a negative 1 to the nth power. We did that in the first lesson. But on the bottom, each of these are just being multiplied by 4. 16 times 4, 64 times 4, 256 times 4. So you have a 4 on the bottom, the 1 stays the same. Your ratio is a negative 1/4. That's how you find your common ratio.